I have been having a ton of fun lately playing around with Hermes, which is a self-hostable AI agent. But the other day I was trying to explain just what an agentic workflow was to a friend of mine, and I kind of realized I didn't really know myself. This whole space is just drowning in buzzwords and terminology, things like agents and harnesses and runtimes and tool access, memory, sandboxes, gateways. You get the idea. So in today's video, I want to cut through some of that noise and try and give you a mental model to help you understand what an agent is and what all of these different pieces are actually for. Then at the end, I'm going to talk a little bit about my Home Assistant and Hermes setup for what I think might be genuinely the most exciting development in how I control my smart home in years. I think many of us by now have a pretty fair idea of what an LLM is capable of. You type something into a chat box in a website and the model behind it goes away and does a bunch of stuff and predicts a useful response. Sometimes that response is genuinely impressive and sometimes, let's be real, it just isn't. On its own, an LLM can explain code that you give it, it can explain and summarize documents that you give it, and it can draft emails as long as you give it the right context. But these models get much more powerful and much more useful when they can connect to your actual stuff, like your code base, your documentation, the logs on your server right now, and in my case, my home automation system. And this is where agents start to come into the picture. The simplest definition that I could come up with was this. An agent is a model running inside a loop with access to tools. And that loop is the important part. A normal chatbot answers your question and then just stops. We've all seen that in the browser. You ask it a question, it replies, and that's the end of the interaction. But an agent can decide on what to do next. It can call a tool, it can observe the result, update its understanding based on that tool call result, and then decide, what am I going to do next? So whilst a chatbot might say, you should probably check your logs, sunshine, an agent can say, assuming it has the right access of course, it can go and actually check those logs for you, read the result, notice that a disk temperature has been high for a week, and then suggest or even take the next action on your behalf. And that's the big shift with an agentic workflow. You're moving from this here is an answer mode to here is the work I did based on what I found in your actual systems mode. Now, the model itself is only one part of this whole agentic system. I tend to think of the model a little bit like the brain. It does the reasoning, the writing, the summarizing, the planning, and the decision making. But by itself, it cannot see your files. It doesn't know how to talk to your server. It can't inspect your calendar, and it certainly can't run commands on your local systems. For that, it needs access to tools. And even a simple action like reading a file is a tool call. Searching the web, also a tool call. Running a shell command, tool call. Sending a Slack message or a Telegram message, tool call. You get the idea. Tools are how the model reaches outside of that chat box. But once you give a model tool access, permissions become absolutely critical. There is a huge difference between, hey, go read this file once that I uploaded into your chat window versus here is full shell access to my machine as root. Good luck, everyone. And that's where sandboxes come into play. A sandbox limits what the agent can see and do. Maybe it can only access one directory. Maybe it needs approval before changing files. And this should sound familiar because your phone probably already prompted you today asking for at least one set of extra permissions to access your location, access your photos, or your microphone. Agents, to be safe, need that same kind of sandboxing, that same kind of thinking. Give them the minimum viable access required to do the task, because if a model misunderstands a request or a prompt injection tries to steer the model somewhere weird or insecure, you need a way to limit the blast radius. So we have the model, we have the tools, and we have the permissions, and now sandboxing. The next piece is the harness, or what people sometimes call the runtime. People use those words interchangeably, which is where some of the confusion comes from, I think. But practically speaking, a runtime, or a harness, is the system wrapped around the model. It manages the loop and it decides how prompts are assembled. It decides which tools are available to the agentic loop, what context gets passed into the model, and how memory is saved, as well as managing the results flow back into the next steps, if there is one. Without a harness, you mostly just have plain chat. And with a harness, the model can work inside of a managed environment, reading files and calling tools and remembering previous work and context, and iterating towards a much more actually useful outcome. That is the agentic stack. The model does the reasoning, the tools let the model perform actual tasks and actions, the sandbox limits what those tools can do safely, and the harness just manages that entire process. It manages that loop. And memory and context also help the agent avoid starting from zero every single time. Now you put all those pieces together and you, my friend, now have an agentic AI workflow. And this is where Tailscale's Aperture fits in. Once you start experimenting with agents, you might want to use different models. You might want to use a local model, OpenAI, Anthropic, or some other provider through AWS Bedrock perhaps. But you probably don't want API keys scattered across every laptop and every server or container, and Aperture sits between your agent systems and those model providers, giving you a secure, observable gateway for model access, routing, usage tracking, access control, and API key management. The harness is still managing the loop, but Aperture manages how those systems talk to the actual models. And this is why people get so excited about projects like OpenClaw and Pi.dev and Hermes and Claude Code and Codex and all these other tools. These all plug into Aperture absolutely seamlessly. So what can you actually do with all of this? Well, over the weekend, I started playing around with Hermes and hooked it up into my Home Assistant. Hermes is a self-hostable agent runtime. In fact, it's just running on the framework desktop just down there, just in the back of shot here. And that's the really nice bit here. Like, Home Assistant is already sat inside my network, and Hermes can reach it securely over Tailscale without me exposing Home Assistant to the public internet or punching random holes through my firewall. So the trifecta here becomes Telegram as the interface, Hermes as the agent doing the reasoning and the tool usage, as well as doing the self-improvement and memory side of things that Hermes is really good at, and Home Assistant as the system, the test case being controlled here. And that combination, I'm telling you, it's really, really powerful. And like I say, for many, many years, I have wanted natural language control for my smart home. I want to be able to type a random sentence into Telegram chat like, the kitchen is too hot. Now, to you as a human, you understand the context immediately. But for a machine, it's pretty hard for them to figure out what I mean when I say, the kitchen is too hot. You know, because you are a human and this is how we work, is that the kitchen is in a specific part of the house. You know that that part of the house probably belongs to a specific climate zone and that there is a thermostat in that climate zone. So when I say I'm too hot, you just go turn the thermostat down, right? But with an agentic workflow, Hermes can take that context coming in from Telegram, go and query Home Assistant, figure out which devices are in which zone, and reason its way through that problem, and then come back to me within a few seconds and go, I've lowered the temperature on the downstairs thermostat. It's amazing. It's really, really cool. The agent can now read the relevant Home Assistant context and figure out what I meant and take the right action. This is such a big step forward from previous smart home automation attempts with AI that I've tried, using the Home Assistant AI pipelines and Olama and all this kind of stuff. The fact that Hermes can self-improve and do this improvement loop and memory and all that kind of stuff, I'm telling you, I think it's pretty much here. I can scarcely believe it. Like just this morning, another example, like I woke up and asked my Hermes bot, why is Jellyfin not working when my kid went to play Paw Patrol this morning? And it went an SSH to the right server, figured out the issue, moved a file around and restarted the Jellyfin container and then fixed things without me leaving the Telegram interface whilst I was eating my cornflakes. Behind the scenes, so much amazing technology made that happen. And it was 100% self-hosted on my local network, accessed using Tailscale SSH behind the scenes to give Hermes secure access. It's just so cool. You've got to understand though that agents aren't magic. They're not a new kind of model. They are just normal models with a wrapper around them that allows them to use the context and the tools and everything else that we've talked about in this video. So if any of this sounds interesting to you, please come and join us over in the Tailscale Discord in the Aperture channel. Let us know what you're building with agentic workflows, whether it's Home Assistant fixes or Jellyfin or Hermes or OpenClaw, Pi.dev, whatever it is, we want to hear from you. So thank you so much for watching, and until next time, I've been Alex from Tailscale.